Welcome students in revision of the lesson number 3, that is the electrochemistry, and we are going to study about the revision of this lesson. Hope that you will enjoy this revision. Dear students, in previous topic we have studied about the electrochemistry, electron and chemistry, that means the electricity developed by the chemical. That was the our topic, and we know that redox reaction can develop the electricity, and that's why first we will know about the redox. Redox is word with reduction and oxidation. Oxidation, it is the defined as the loss of electrons, while reduction is defined as a gain of electrons. In a redox reaction, both oxidation and reduction reaction take place simultaneously. Direct redox reaction, the direct redox reaction is there, that is happening in one vessels only. In a direct redox reaction, both the oxidation and reduction reaction take place in the same vessels. Chemical energy is converted into the heat energy. That is our point to know about that. Okay, then next one is indirect redox reaction. The indirect redox reaction are those redox reaction in which oxidation and reduction take place in different vessels. In an indirect redox reaction, chemical energy is converted into the electrical energy. So direct redox reaction is happening there only. The chemical energy is going to convert into the heat energy. Indirect reaction, the chemical energy is going to convert into the electrical energy. Now, electrochemical cell. Here, this figure providing the electrochemical cell, and you know the half cell in which oxidation take place is known as oxidation half cell, and the half cell in which the reduction take place is known as reduction half cell. Oxidation take place at anode, which is negative charge, and reduction take place at the cathode, which is positively charged. Transfer of electron take place from anode to cathode, while electric current flows in the opposite direction. An electron is made by dipping the metal plate into the electrolytic solution of its soluble salt. Copper sulfate. Zinc sulfate is our target. A salt bridge is a U-shaped tube containing an inert electrolyte in agar-agar and gelatin. So these are two new words for you, agar-agar and gelatin, that you can understand. Now next, salt bridge and the representation of cell. Now just we have discussed about salt bridge. A salt bridge is a maintains electrical neutrality and allows the flow of electron current by completing the electric circuit, and that is our point to know. Representation of an electrochemical cell. So anode is written on the left while the cathode is written on the right. That is our knowledge. Anode representations done like metal by metal. Okay, if you know, then we were writing like this. કે એનોડ ને લખવાનું હોય તો સપોઝ કે Z પર ઝિંક છે તો ઝિંક નું representation we were doing like this, and Zn plus 2 ion. So this is the representation of anode, and cathode representation can be done. अगर cathode पर copper બદલાવાનું છે તો copper plus 2 represented with the copper. So this is the copper no. So hope that you understand this point. Okay, કે કોને કઈ રીતે લખવાનું છે તે. Salt bridge is indicated by a placing soluble vertical lines between the anode and cathode. So that is the representation entire. કે અહીંયા representation કરવાનું હોય તો પછી અહીંયા આવશે બે vertical line, અને બે vertical line પછી આપણે લખી દેવાનું હોય Cu plus 2 Cu. So that's all in this thing. So hope that you understand. Now electrode potential is a potential difference that develops between the electrode and its electrolytes. So electrode potential ni definition આપણે જાણીએ છીએ. It is potential difference that develop the electrolytes and electrodes. Okay, the separation of charges at the equilibrium state result in the potential difference between the metal and the solution of ion. It is the measure of tendency of an electrode in the half shell to lose or gain the electron. Loss of electron, then it is known as different. Gain of electron, then it will known as different. So dear students, here we are talking about the electrode potential. Standard electron potential, when the constant concentration of all the species involved in the half shell is unity, then the electrode potential is known as standard electron potential. It is denoted by E degree. According to the present convention, standard reduction potentials are now called standard electron potential. So now onward, standard electron potential is nothing but the standard electrical potential and electric potential, both are same. So now next topic is type of potential. Potential can be divided into two types. Type of potentials are two: oxidation potential and reduction potential. Oxidation potential, it is the tendency of an electron to lose electron or get oxidized. To lose electron is known as oxidation potential, and reduction potential means to get electrons means reduction potential. So that is our next point to be remembered. Oxidation potential is the reverse of reduction potential. So एक प्लस લીધું તો બીજું તમારે લેવું પડશે minus. The electrode having a higher reduction potential have higher tendency to gain electron, and so it act as a cathode. જેના પાસે વધારે છે એ cathode કારણ કે ખેંચી લેશે, whereas the electrode having lower reduction potential acts as a anode. So low value anode, high value cathode, we have so many times discussed. Okay, then the standard electrode potential of an electrode cannot be measured in isolation. Standard આપણે isolation કરીને મેળવી શકીએ નહીં. So always these are the comparative value. And the hydrogen electron which has potential 0, and using hydrogen electron we are able to measure the standard potential of all. Reference electron. The hydrogen electrode is known as reference electron. The standard calomel electrode can also be used as a reference electron. Not only hydrogen, okay. Calomel also used as a, so this is new word for you. SHE. SHE is full form is standard hydrogen electrode. Consists of a platinum wire cells in a glass tube and carrying platinum foil to one end. That figure you have seen. The electrode is placed in a beaker containing an aqueous solution of an acidic having 1 molar concentration, and that all we have studied. So you can read this by figure and you can remember this. So this is our reading task just now. Okay. Now hydrogen can be written in two form. If it is used as a anode, then this will be, and if it is used as a cathode, then this will be. So there are two types of hydrogen you can take, as anode also as well as cathode also. Anode તરીકે તમે એને આ રીતે ગોઠવી શકો છો અને cathode માટે તમે એને ગોઠવી શકો છો. So these are the reactions of the anode and cathode according to. In the electrochemical series, various elements are arranged as per their standard reduction potential. Standard reduction potential નું higher value થી lower value ની અંદર we are representing them. So now how they are representing, that is the known as EMF series. A substance with the higher reduction potential value means that it has a higher tendency to get reduced. So it is act as a good oxidizing agent. So now these we have explained in the first video. Now here also I am explaining for you a substance with a higher reduction potential value means that it has a higher tendency to get reduction. જેટલી વેલ્યુ વધારે રિડક્શન વધારે, બરાબર. That's why it will behave as an oxidizing agent. એટલે ઉપરવાળા જે છે એ oxidizing agent છે અને નીચેવાળા reducing agent છે. That is the substance with the lower reduction potential value means that it has a higher tendency to get oxidized, so it is act as a reducing agent. The electrode with the higher reduction potential act as a cathode while the lower electrode as a anode. The potential difference between the two electrodes of a galvanic cell is called cell potential at a measured in volts. બેના વચ્ચેનો ડિફરન્સ, દાખલા તરીકે કોપરનો કેટલો હતો 0.76 અને સોરી 0.34 અને એનોડનો કેટલો છે -0.76. If you will do, then 1.10, that is the electric potential of the galvanic cell. The cell potential is difference between the, so that you can read, understand.